this video, we'll be going over the test review that you worked in class and that I went over in class. So the first one says, name the following. We're going to use this circle diagram at the top, and we're going to name a chord. So there's a couple of chords here. BC is one. Also AD, even though it is a diameter, is one. And EB is one, or BE. As long as it touches, both ends touch the circle. The diameter, there's only, actually there's two. There's BE and AD. Then it says a radius, we have FD is one. It goes from the center to the circle, so FE is one. FE. We have FA is one, and we have FB is one. A central angle, as long as the vertex of the angle is on the center of the circle and it goes to the circle. So you have EFD is one. AFB is one. These are all angles, by the way. And BFD is one. And AFE is one. As long as it's in the center of the circle, the vertex in all of these is the center of the circle, which is F. An inscribed angle, the vertex is on the circle. So right here is our only angle that's on the circle. So you would name that one angle EBC. Remember that when you're naming angles, the vertex is in the middle. And then tangent line would be this one that touches that circle in one point. And I noticed that there's not two points written on there, so you'd have to do line containing E. Now, E is in two segments. It's in this one and this one, but this one's the only line because it has the arrows. If you're moving on to the next section, you have this diagram and you're doing measures of angles. So angle BEC, if this is 100, this is 100, then I noticed that this should be here. This should not be a separate line there. And it won't be for the test, so no worries. So if that was scooted over there, then BEC would be 180 minus 100, so it would be 80 degrees. A measure of BDC, so it also makes this 80-degree arc. BDC, we'd have that coming straight through that center there. And that is an inscribed angle, so it's half of the arc it makes. I've noticed that I'm going down the column instead of across, so let's look at number 11. Measure of the arc BAC. So if we're going here to here to here, it is 360 minus 80. So it is 280. Am I right? 360 minus 80. Yes, 280. And then measure of arc BC, which we just found out. And measure of arc AEB. And I'm not sure where that came from because that is not possible. That's not an arc. That is a measure though. Maybe I was trying to say measure of arc AB, which would be 100 because of the center angle. So let's move to this one. Measure of angle BCD, measure of angle CBA, and 14 said, is quadrilateral ABCD cyclic? Well, first we need to answer that one first. So it is cyclic because each of its vertices is on the circle. which means the opposite angles equal 180 degrees, the sum of them, if you add them together. So this one and this one equal 180 degrees, and this one and this one together would equal 180 degrees. So B, C, D, and 60 have to equal 180. So you take 180, you subtract 60, and you get 120 degrees. And then this one, you would take 180 and subtract 88, and you get 92 degrees. And so that, yes, is cyclic. A circle has a radius of 15 centimeters and a central angle that measures 96 degrees. Find the exact length of the arc defined by the central angle. So I'm going to go ahead and draw that circle out. And it has a radius that is 15 and central angle that is actually 96. And it wants us to find the length of the arc. So if we remember, this is theta over 360, that is not 0, times, and because we're finding the length of the arc, we're going to use the circumference of the circle, which is this, 2 pi r, or 2r pi. And so we're going to put in the numbers we have now. We have 96 here, and the radius is 15, so 2 of those is 30 pi. So you would then multiply 96 times 30. That would equal 2,880 divided by 360. Let's see if that comes out to be a whole number. It does, so 8, and do not forget your pi. It's very important. If you buy a wedge of cheese shaped like a sector of a circle, so sometimes you buy a piece of cheese that looks like this, and the central angle is 30 degrees, and you have a radius of 7 centimeters. What is the exact area of the top surface of the wedge? So we don't want the whole volume of it, we just want the area of the surface. So when we are looking for the area of a sector, it's almost like the length of the arc that we did in number 15 up there, but instead of by the circumference, you're doing it by the area of the circle, which is pi r squared, or we can put r squared pi. So we're going to put our numbers in now. 30 over 360, and then 7 squared is 49. So now we're going to go 30 times 360. I'm sorry, 30 times 49, and you get 1470. Divide that by 360 to see if it comes out to be a whole number, and I don't think it does. 30 times 49 divided by 360. No, it comes out to be a decimal, so we're just going to leave it like this, but we can also reduce. And don't forget your pi. So, and we can reduce this also by 3. So that goes 49, and this goes 120, and then pi, and then it's units squared, or in this case it would be centimeters squared, and this is exact. If I bought a wedge of cheese, it's the same thing with a central angle. We're doing radians now. So instead of degrees, we have radians, and a radius of 3 inches. What is the exact surface area of the surface area? So if we remember pi over 4, and these are just things that you're going to memorize, but you could figure it out if you have to. So 1/4 of half of the triangle, because we know pi equals 90 degrees, equals 180 degrees. That's half of our triangle. So 1/4 of that, 180 divided by 4, is 45 degrees. So this is 45 degrees here, and then you're just going to find your area just like before. So the only extra step we had to do was figure out how many degrees that was in. So 3 squared is 9. So we're going to go 45 times 9 is 405. 360. This is pi. We can divide that by 5. We get 81. And 360 divided by 5 is 72. And then we can divide this also by 9. So 9 goes into 81 9 times, goes into 72 8 times. And it is units squared. What were the units? Inches squared. It's that radius. If you remember from the lesson 12 in unit 7, and we did a bunch of degrees to radians, and it was a portion of the circle. We know that 180 degree is pi radians, and then when we go 360 degrees, that's 2 pi radians. So pi over 3 from that list was 60 degrees. And then 45 degrees goes in to 360 8 times. And so if we did 1/8 times 2 pi, that is our whole circle, and we get 2 pi over 8, and we reduce that, we get pi over 4. So 45 degrees is pi over 4 radians. 2 concentric circles have a radii of 8 centimeters and 10 centimeters. You may see respectively, meaning the first one's 8 centimeters, the second one's 10 centimeters. You can, how many centimeters longer is the circumference of the larger circle than that of the smaller circle? So if concentric means they share the same center, so if we zoom in, and one is 8 and the other one is 10, this whole thing is 10. Well, let's just find our circumference. Our circumference is 2r pi, or 2 pi r, same thing. So the first one, the smaller one, is 2 times 8 pi. And so we would get 16 pi. And the other one is 2 times 10, so 20 pi. And if we subtracted the two, 20 pi minus 16 pi, the pi's don't go away, but it is 4 pi centimeters longer. The larger circle is 4 pi centimeters larger. I see a mistake that I made in 21, and it had at the end, what is the length of each of these 3 arcs? It should have been, what is the length of each of these arcs, or the arcs. It should not have the number 3 in there. So this says a circle with the radius of 5 centimeters is divided into 4 congruent arcs. So if I have a circle and it's divided into 4 arcs, that means 360 divided by 4 is 90 degrees. And it wants to know the length, not the measurement. 90 degrees is the measurement of the arc. But that means this central angle is 90 degrees. We already said the radius is 5 centimeters. So we're going to use this, theta over 360 times 2 times 5, which would be 10 pi. And instead of theta, we will put 90. So 90 times 10 is 900 over 360, and that does not go evenly. So we'll just reduce it down to, we can do 90 over 36 pi, and that can go even further. Divide by 9, so 10 over 4 pi, and that can go even further, and divide by 2, so you'd go 5 over 2 pi units or centimeters is the length of the arc. This one, the shaded arc below is bounded by the radius AB and CB and minor arc AC. The length of AB is 8 meters, and the area of the shaded sector is 48 squared meters. What is the measure of the angle? So we're using our area of the sector, which is this. So we're going to put everything we have in here. The area is 48. Theta is, we don't know, that is what we're looking for, the central angle. And then r squared would be 8 squared, which is 64 pi. And we are going to now solve for theta. So I'm going to keep theta and 360 together as long as I can because they're in a group together. So now this is, I'm sorry. Yeah. So now I'm going to do 48 and divide by 64 pi. And you notice the ones we've done before, we've had a pi right here with this, but this time we don't, which means we're going to do this and have a decimal. So I'm just going to hang on right now. We don't even have to put it in yet. We can do it at the very end. And then we have 360 divided into theta. So we're going to multiply it. And our calculators are pretty smart. We can do all that at the same time. So if I do 48 divided by 64 pi times 360, and we are going to get, we will get 78.8 degrees. Of course, we will round because we actually put pi in there. A circular spinner dial for a new board game is divided into 5 congruent sectors. What is the arc measure of each sector? So if I have a circle, I've got to divide it in by 5, so 360 divided by 5 equals 72 degrees. That's all it's asking, nothing special on that one. On 24, it's asking for the measure of the minor arc, which would be this smaller arc, because major arcs are over 180. And if we know that all the way around the circle is 360, this central angle is 200, this arc is 200, so we have 360 minus 200, which is 160 degrees. For this one, it says a pizza place is selling 1 slice of a 10-inch pizza for $4 and 2 slices of 12-inch pizza for $4. And the company cuts all pizzas into 8 equal slices. Which one's a better deal? So if we have 1 inch of a 10-inch pizza, that means that my radius is half of that, it's 5. And if it's in 8 equal slices, 360 divided by 8 is 45 degrees. And so I'm going to find the area now. So once I do 45 divided by 360 times 2 times, we're going to do the area, so 25 pi, and you get 9.8. And this would be inches squared. The other one has 2 slices of pizza, and it's a 12-inch pizza, so half of that is 6. So this is 45, this is 45, because it's still cut into 8 equal slices. So if we just turn this into one big slice, we can just do our area one time with 90 degrees. So we go 90 divided by 360 times 36 pi. We have to square our radius. So I have 90 divided by 360 times 36 pi and you get 28.3 inches squared. So, and it says, explain your reasoning. So, obviously, this one's the better deal. You get more pizza. And so, explain your reasoning. If you can't show me this work, then you're going to tell me that, hey, the one with the 2 slices is the better deal because you get more pizza because I found the area and you get more. And you can tell me what the area of the 2 are, but use your words. Now, it's not going to always, just because it's 2 slices, be more pizza. You have to figure out, this may come into play. They may cut one pizza in more slices than the other. So you're going to have to take all those into consideration.